Hello and welcome to my Prezi. This Prezi will be done to support English language learners or English literacy development students in a specific subject. My name is Kasha Anderson, so welcome along for the ride. So the course or the unit I looked to explore is the grade 10 academic science curriculum. So I looked at specifically the chemistry unit, and this unit was designed with an overarching question. So let's explore the unit and then we'll explore how we supported ELL students. The link right here is the website that contains the whole grade 10 science curriculum. When I designed this curriculum, I looked at the chemistry unit, the biology unit, the earth and space unit, or so the environment unit, and the physics unit. Today we're going to focus solely on the chemistry unit and how that unit would be designed to support English language learners and English literacy development students. But firstly, let's look at how I designed the unit prior to this course. So this is a PDF including the unit plan. So here we have the curriculum course expectations. We've got the big ideas. This unit was designed to take 20 days because the chemistry unit basically has, or the chemistry course has 4 different units, and each of these units takes about 20 days to cover. So it will look at every single chemistry curriculum criteria. So analyzes the variety of safety, environmental issues associated with chemical reactions, including the ways in which chemical reactions can be applied to address environmental change. That's a big one that we're going to touch on. Investigating through inquiry the characteristics of chemical reactions, and demonstrating an understanding of the general principles of chemical reactions and the various ways to represent them. So that's what the grade 10 chemistry unit does. It talks about physical and chemical matter and properties. It talks about nomenclature, addresses balancing chemical equations, some of the chemical reactions, the laws of conservation of energy, and such things. Oh, I actually want to go to this one. Okay, so when we look at this one, the unit is sort of designed in several tasks that would take a couple of days to do. It does touch on all those big ideas of relating technology, science, and the environment, developing skills, strategies, and habits of mind required for scientific inquiry, and understanding the basic concepts of science. So let's put that aside and I'll kind of explain how I designed this unit. So in the chemistry unit, as I mentioned, there's several components we need to hit. So what I did is a backwards unit design where the whole process of learning is designed to answer a driving question. So this goal, or my goal in designing this unit, was to get student buy-in in terms of actually learning the chemistry. So instead of just asking students to follow you down a journey of learning, you get a buy-in because they need to answer these questions in order to answer the overarching question. So our overarching question was, what is the environmental impact of owning a cell phone? So in the first day of this task, we sort of have a discussion. What does that mean? Environmental impact. How do we measure impact? And eventually you lead students down the path that they need to determine how much carbon dioxide is emitted, so your carbon footprint. And basically the process is student driven because they start down the path of answering how much carbon dioxide, and they realize, oh, we're coming up with all these elements that we don't know their names, or we come across these chemical reactions and we don't even know what a chemical reaction is, or how to balance a chemical equation, or what is the difference between physical and chemical change. So along the way, students get held up. And they get held up basically day 2, where they realize, I don't know any of these elements. I don't know what an atom is, where these elements are on the periodic table. So the teacher takes a step back and says, oh, shoot, we can't do this without knowing this. Let's go to the periodic table. Let's classify matter. Let's look at the atomic structure. What are electrons? What are protons? What is the atomic weight? And gets the students buy-in into doing this sort of chemistry, the directed questions. And then we could go into nomenclature and how do we name compounds, and what are the chemical and physical changes. And once the students are build up their science knowledge, we can then go back to the driving question again and say, okay, now I know how these reactions work. I know how to balance them. Let's balance them to see how much carbon dioxide is emitted. Oh, well, again, now we're dealing with another unknown. What are these chemical reactions? Which ones give up carbon dioxide? What are the different like smelting reactions and things like that? So again, the students have to step back. We go into directed learning, and this is like task 3 that I'm looking at, and we look at conservation of energy, how to apply the conservation energy to chemical equations. And so the whole time students are working on this driving questions, and they don't always have to be working in the same groups until sort of where we get to task 4, when they start establishing a group. And we're supporting the learning with meeting all the curriculum goals and criteria that need to be met. So then we talk about, a climate change, what is a carbon footprint? Again, that's needed to answer our questions. So we're constantly going back and forth between working on the question and working to support the knowledge we need to be able to answer the question. So when I initially designed this, I talked about, that this classroom is a very holistic science course, which is really directed at the students and is driven by the students' learning. So every class you have, every group of children, this will be a very different experience than the previous year or the following year, because students will look at different aspects. Like some students might just look at the, when we're talking about the impact of owning a cell phone, they might just look at the manufacturing aspect of a cell phone. Whereas you might have other years or other groups that look at, the transportation to get the cell phone to the site, the extraction of the chemicals or the elements from the earth and the carbon give off. You might have groups that want to look at the carbon footprint of owning a cell phone and how long, or we might talk about how many cell phones somebody might own over a lifetime. And that might not just be looking at one cell phone, might look at the variation of students. So what's nice about this is there's no one answer at the end that every group is supposed to get. The path that they take and what they choose to include can vary. And so that actually makes it really easy to modify this task and the activities that we do within this for various levels of learners. So we have what we call low floor, high ceiling format, which means that every student can embark on this mission, and where they choose to stop is dependent on the students. So some students will look at it in a very low level, look at maybe one element and how much the whole life cycle of that element, and only address, let's say, copper, which is one of the elements that cell phones are composed of. Or we have other students who will look at 20 different elements that a cell phone is composed of, and look at every single one of the processes that's involved to get that element to from extraction to manufacturing into building into the cell phone, and then the recycling of that element even. So you can make it as big or as small as you want, which leads it to be a very nice one for ELL students. So when I initially designed this this task, I looked at it as I put out a calendar and what we would do on each day, how we were hitting the different tasks. When would I have to interject sort of the directed lessons, like when you see this focus here on this chart, like focus on matter, what atomic structure is, the periodic table. So these are when the teacher is doing sort of more directed lessons and pulling back throughout. And throughout these tasks, let's just go back here because I noticed we jumped ahead. Throughout these tasks, the teacher is doing assessment as of and for. Oh, that was on this one here. As of and for. And so you can see a lot of the assessments as are ongoing. So throughout the classes, students are allowed to go pick up quizzes, self-quizzes that they do, that they would peer assess or self-assess to see where their learning is. There's a lot of like handouts that would be given out to students that they would complete and hand in. There's a lot of think, pair, share activities, a lot of building the class up together. And there are also tasks that students would be doing on their own individual tasks. And we'll look at those in a little more detail when I'm talking about how do we fit in the ELL learner. So let us go to what I initially said when I was making this unit plan. I did actually make accommodations for differentiated instructions and practices, and I did include ELL, and I called them ESL learners at the time. So I didn't actually include English literacy development, but I looked at as ESL or ELL learners. And the only accommodations I really made, other than the fact that all the assignments have low floor, high ceiling, is I said support ESL and ELL learners in your class by speaking slowly and clearly. When possible, translate content information into the student's mother tongue. Allow students to use translation apps and or visual gestures, props, and manipulatives. So, I mean, it looks like I did make some sort of accommodations, but they are very superficial accommodations. They didn't really speak to anyone or individuals in my classroom, and they didn't really address any of the fact that students, ELL students, are of different steps, so that they're not all at the same development in their English language proficiency. So stuff like, speaking slow and clear, of course, would help and be beneficial to all my students. And the use of translation apps or dictionaries, again, it can be very helpful to students who need it, especially level 1 students. It might not be necessary for a student like a student on step 3 or 4. So let's look, now that I've been assigned this task, let's look at the modifications that I would do.